Swayam Prabha. Digital India. Educated India.
Namaste and welcome back to the video course on watershed management. Today we will start a new module, module number 7. So, in this module there will be 4 lectures, lectures 27, 28, 29 and 30, and the module title is Management of Water Quality. So, this is specific to the watershed related aspects. So, the topics covered in this module include water quality and pollution, types and sources of pollution, water quality modeling, environmental guidelines for water quality. So, today in lecture number 27, in this module number 7, we will discuss about surface water quality and pollution issues. So, some of the topics covered in today's lecture include water quality, pollution sources, types of pollution, water quality parameters, water quality standards. Some of the keywords for today's lecture: water quality, pollution sources, types of pollution, parameters, standards. So, as we discussed earlier, say as far as watershed management is concerned, so water as a resource what we consider. So, we have to see that the water availability, the quantity of water is very important, but of course, when we deal water as a resource, the quality of the water is also very important. So, we have to see that the available water is protected, so that the quality is good. So, while studying the quality of the available water, we have to see the whether there is any pollution has already taken place. If the pollution is taken place, what is the amount of pollution and what are the components of that pollution within the water, and then what are the sources of pollution, so that we can see that whether we can reduce those pollution or go for some remedial activities. So, that way when we discuss about watershed management, water quality is very important issue. So, let us look into various aspects of water quality as discussed in this slide. So, as I mentioned, watershed management is concerned, water is the most important resource as what we consider in a watershed. So, water quality and quantity both are important. So, not only the quantity, but quality also should be good. So, simply available, so if more water is available, it does not mean anything, but quality also should be good for safe usage, say for domestic, say for drinking purpose or any other purposes. So, then assessment and monitoring of water quality is very important, that way as we discussed, and say this is very important as far as livelihoods of watershed dwellers, that means the people living there. So, it may be water used for domestic purpose, drinking purpose or irrigation purpose, whatever the purpose. So, it is very important that the quality is assessed properly and monitored, so that the safe water or good water is available to the people. So, water quality actually means we have to see that what are the components, whether it is exceeding certain limits of the whatever is considering. So, water quality gives the examination, or water quality is the examination to determine whether there is any organisms, minerals and the organic compounds within the water, whether it is say exceeding other, say compared to certain standards. So, that is what we are trying to do through water quality analysis. And then this say the standards are concerned, the standards varies depending upon the use. So, for example, drinking purpose is concerned, we want the best quality, and but say for example, for irrigation purpose or other purposes, the quality will be different, or industrial purpose the quality can be different. So, that way we have to assess the quality of the available water. So, through physico chemical say examinations or chemical tests and microbiological analysis. So, that way various types of analysis, physico chemical, chemical or microbiological analysis are very important. So, when we consider the water available within a watershed, say as we discussed, the water can be either surface water, just like what is available in a lake or in a river, or it can be groundwater which we are extracting from the aquifer systems, say through tube wells, boreholes or the open wells. So, some of the important issues which generally we have to see that, say the water is not affected by bacteriological pollution or pathogenic pollutions, and then how much is the salinity or the dissolved solids within the water, and then say any toxicity is there in the water, say like micropollutants and other industrial pollutants which may say percolate into the water resources like in a river, lake or to the groundwater system. So, these are some of the common issues which we have to deal when we discuss about the water quality, a surface water quality or groundwater quality. Say when we discuss, we have to see, we have to analyze various samples and then see that whether any pollution is there, and then compare with the standards like World Health Organization standards or Indian Standard Institute standards or various types of various country standards. And then say if it is not meeting, then we have to see what can be done. So, that is what we have to discuss, we have to see as far as water quality is concerned on a watershed basis or when we deal with the watershed management. So, now let us see the important aspects related to water quality standards and water pollution, etc. So, water quality as I mentioned indicates the physical, chemical and biological characteristics of water. So, water quality indicates how is the physical like color, then what is the turbidity, what is the taste, then chemical like say how much TDS is there, total dissolved solids are there, or whether any say heavy metals or any other chemical pollution is there, then biological characteristics like it is the pathogens are there. So, then generally as far as water quality standards are concerned, it is a measure of the condition of water relative to the requirement of one or more biotic species and or to any human need or purposes. So, as I mentioned earlier, whether it is for human consumption or whether it is other purposes like irrigation or industrial. So, according to the needs we have to assess the quality of the water. So, it is most frequently used by reference, I mean the water quality standards by reference to a set of standards. So, say like WHO or World Health Organization standards or Indian Standard Institute standard, BIS standards or say US Environmental Protection Agency standards. So, like that various standards are available. So, we will be comparing with those standards with respect to the by going through various tests, and then we will see that whether compliance is met as far as the particular samples or particular source is concerned, and then we have to see whether that particular usage is permitted or not. So, the most common standards used to assess water quality related to health of ecosystems, safety of human contact and drinking water is generally the most common standard is with respect to World Health Organization standards. So, we have to see say the various we have to go through various tests and then see that the samples are complying with these standards, and then accordingly we can decide whether water can be used for domestic or industrial or agricultural or various other purposes. So, then when we discuss about the water quality standards and categories, say we as I mentioned, when we do this kinds of analysis we can categorize into various category depending upon the usage of the water. So, say for example, when we are discussing about human consumption. So, here we are using the water for drinking purpose including bottled water. So, this our cooking and other purposes. So, may reasonably be expected to contain at least small amounts of some contaminants. It may not be the purest form of the water just like say the rainwater or distilled water, but maybe some say total dissolved solids or some minerals etc. will be there within the water. So, presence of these contaminants does not necessarily indicate that water poses a health risk. So, say human consumption we are not looking for purest form of water just like a distilled water, but there can be some type of contaminants or minerals within the water. Then as far as industrial use is concerned, say the dissolved minerals may affect suitability of water for a range of industrial and domestic purposes. So, depending upon the industrial use, say for example, the hardness of the water, say if calcium and manganese which interfere with the cleaning action of soap and can form hard sulphate and soft carbonate deposits in water heaters or boilers. So, hard water may be softened to remove this type of ions. So, wherever if the water is hard we have to make it soft depending upon the industrial purpose. So, that way we have to do some chemical treatment. So, similarly, if we, for human consumption, say to make it palatable, we have to purify it, go through filtration process or chlorination, like that, depending upon the requirement. So, that way, depending upon the use, we have to see. Then say as far as say the environment, in the environment, say like say ecological use for the agricultural uses or whatever the uses. So, in the environment is concerned, the toxic substances and high populations of certain microorganisms can present a health hazard for non-drinking purposes such as irrigation, swimming, fishing, rafting, boating and industrial uses. So, as far as these types of uses are concerned, that means this is we classify as environmental use, say for plants or ecosystems or fish or that kind of purposes. So, here the standards will be different. So, these conditions may also affect wildlife which use the water for drinking or as a habitat. So, here say for example, some of the components can be higher, since we are not strictly following whatever is for human consumption. So, that way it will be standards will be different. And then of course, for irrigation purpose, say as we can see that say overall the world, say about 70% of the water usage for irrigation or crop requirements, or in India especially it is going to 80 to 85%. So, that way irrigation water quality requirements, it will be different. So, we do not have to go through these kinds of treatments, but of course, some of the components like salinity and other parameters are very important, otherwise the crop will be affected or crop growth will be affected. So, agriculture is the single largest user of fresh water. A major cause of degradation of surface and groundwater is also can be coming from the agricultural usage, say like when we are putting fertilizers or herbicides or pesticides, that may leach into surface water or groundwater. So, that agricultural it can be a source also, but for irrigation purpose, for crop use purpose, the standards will be different. So, that way water quality categories like human consumption or the industrial use or the ecological purpose or irrigation purpose, the various standards are available. So, accordingly we can decide the available water is suitable for that particular use or not. And now, let us discuss what are the important sources of this type of pollutions when we consider a watershed or a river basin, say what are the various sources of pollutions. So, water pollution as I mentioned is the contamination of water bodies. So, like either lakes, water in lakes, rivers, oceans or groundwater. So, say whenever certain components are exceeding certain limits, so that is what we call it as contamination. And then water pollution occurs when pollutants are discharged directly or indirectly into water bodies without adequate treatment to remove harmful compounds. Say for example, if an industry is there, industrial effluents. So, it is coming through a large number of processes within the industry. So, certain components may be much more higher than expected for the certain, say with respect to certain standards. So, that way say if you do not treat the industrial effluent to the acceptable limit, then that become a source of pollution. And then this water pollution affects plants and organisms living in these bodies of water. Say the plants or aquatic life will be affected due to this pollution, or the water which is utilized by the plants for irrigation or other purposes, then that also will be affected. So, the effect is damaging to individual species and populations and natural biological communities. So, that way we have to see that the water available is of good quality for the intended use. So, now water pollution source is concerned, we can generally classify into two types. One is so called point source and another one is so called non-point source. So, that depending upon say what is coming and then polluting. So, that is according to that classification is done. So, first one is water pollution point sources. So, point sources means contaminants that enter a waterway from a single identifiable source such as a pipe or ditch. Say for example, the effluent coming from an industry directly putting to a lake or putting to the ocean or putting to the river. So, that is coming as a point source, or the effluent the coming from the effluent treatment plant or the drainage systems. So, that this or we can consider as point source. So, this point source we can trace to specific source. So, it can be leaking chemical tank, effluents coming from a waste treatment or industrial plant, or a manure spill from a hog confinement lagoon, etc. So, number of examples like discharge from a sewage treatment plant, a factory, a city storm drain, municipal storm sewer systems, industrial storm water such as from construction sites, etc. So, there are number of examples, and this point source is a major source of pollution, especially in urban areas. So, urban areas are wherever the appropriate treatment is not given for industrial effluent or the effluent, the sewage. So, then this become a major source of pollution to the water sources like lakes, rivers, or even to the groundwater. So, this point source actually it is easy to identify, since we can easily chase exactly from where it is coming from, and then we can also go for remediation. That means by curtailing that source, or by enforcing agencies to treat that effluent coming from industry or coming from the sewage treatment plant. Then that way we can go for remediation or go for controlling this type of point source pollution. So, point source pollution is easier to deal as far as water quality is concerned. We can try to control through various means easily. And then other one is so called non-point source of pollution. So, here the non-point source of pollution, or NPS, the contamination that does not originate from a single discrete source. So, we cannot easily identify whether it is coming from the one particular industry or like that, but it is generally from the say agricultural lands or the sedimentation coming from the watersheds, etc. So, NPS or non-point source of pollution is the cumulative effect of small amounts of contaminants gathered from a large area. So, this is coming from like overland flow or the paddy fields or the irrigation water or the crop water which we provide, and then when we put fertilizers or manures or herbicides or pesticides. So, these all will be leaching or to the groundwater system or directly joining to the streams or rivers. So, these pollutants will come from widespread area, as I mentioned. They cannot be tracked to a single point or source. So, like soil erosion, chemical runoff, animal waste pollution, etc. So, examples like leaching out of fertilizers, nutrients from agricultural lands, nutrient runoff in storm water, agricultural field or forest, contaminated storm water washed off of parking lots, roads and highways called urban runoff. So, these are some of the examples as far as the non-point source of pollution is concerned. So, this non-point source of pollution, say even though we can identify the how much is the pollution by taking samples from the particular sources, but it is not so easy to identify these sources, and then the controlling these sources also become very difficult, and that way the remediation also become difficult. So, this actually say if you consider the overall water quality issues or water pollution sources throughout the world is concerned, actually non-point source of pollution is a major source of pollution compared to point source. Since point source mainly we can easily identify from where this contamination is coming, like industries or sewage treatment plant or whatever it is, but here non-point source of pollution it is very difficult to identify, and then controlling also much more difficult. And now say let us discuss say within this context say especially point source, say what are the specific sources as far as water pollution is concerned. So, here I have listed some of the specific sources like septic systems. So, where say here septic tank we use a large tank buried in the ground to contain and break down household sewage, fats, oils and grease, as well as large waste particles. They are stored and later pumped out of the holding tank after keeping some time, so that some stabilization takes place. The source of actually this septic tanks are source of pollution, concerned to groundwater especially, and then surface water if there is any direct leakage. So, like you can see that there is the inlet to the septic tank, and then we keep it for some time, and there some of the things settle down, and then this is, say, if any set breakage for this system or overflow takes place, then that become the source of pollution either to groundwater system or the surface water systems. And then sources like lagoons, say where shallow holding pits, you can see that here shallow holding pits into which wastes are pumped and treated, say like in cities when we go for severe treatment plants, we put in this wastewater into lagoons. So, water quality problems like poorly constructed lagoons, like leakage can take place from these lagoons, and lagoons built on high water tables, so that it can penetrate to the aquifer systems, and from here nitrates and various other heavy metals, all this pollution can take place. Then say waste disposal plants like underground or above ground disposal practice or domestic, municipal or industrial liquid waste. So, how we are treating, say, the waste disposal. So, waste disposal especially in where our industries or cities are concerned is a major problem. So, if this waste especially wastewater is not collected properly and then treated through various systems, then it will become say this water will be joining to the lakes, rivers or to the ocean, and then also it will be seeping down to the aquifer system. So, that become a major source of pollution. So, waste disposal or waste water is one of the major source of say water pollution, say to the surface water as well as to the groundwater. And then some of the other specific sources here I have listed, like industrial liquid waste, as I mentioned, treated or untreated. Then also solid waste, say like say solid waste, especially in cities, we do land disposal, say like landfills will be constructed, either scientific landfill or unscientific, whatever is many of these what are in India, say for example unscientific landfills. So, these landfills say in particular zones, say when it comes with rainwater, then it is leachate will be say produced, and this will be leaching down to the aquifer systems, or it will overflow through the system to the nearby surface water sources. So, that is from the solid waste. And then storage and transport of commercial materials. So, if any tanks or the say spilling takes place or the tanks breaking takes place, then that will be a source of pollution. Even we can see that in ocean also, when ships say due to the breakage or the say tanker spilling, that can be also source of pollution. Then another source of pollution can be mining operations. So, mines say use a lot of water for various purposes, and that washed water become a source of say pollution. Then oil and gas, acid mine drainage, and leaching of toxic metals, all these become source of pollution. And then as I mentioned earlier, as non-buoyant source of pollution, agricultural operations. So, whenever we put fertilizers, pesticides, that become a major source of pollution. So, whatever fertilizers or manures we put, so that some parts will be only used by the plants, and major portions of this will be coming with the surface water or to the groundwater, and that become a source of pollution as far as the water is concerned. And then another source of pollution can be like in coastal regions, when the seawater is ingressing to the river water, or say the aquifer system, the seawater intrusion takes place to the aquifer system. So, that also become a source of pollutions. So, this various reasons can be there for this kinds of pollution due to the seawater intrusion. So, these are some of the specific sources as far as water pollution is concerned. So, now let us look into what are the important causes as far as water pollution is concerned. So, here in this slide say wide spectrum of chemicals, pathogens, and physical or sensory changes such as elevated temperature and discoloration, all this can be causes as far as water pollution is concerned. So, when some chemical components exceed certain limits, or when pathogens are introduced within the water, so that become causes of pollution. And then say nowadays a huge amount of water is used for say cooling purposes in thermal power plants. So, that become the temperature become another source of pollution. and then naturally occurring like the causes can be naturally occurring like salts, fluorides, arsenic, calcium, magnesium, sodium, etc. So this will be say when due to rainfall or water passage over these kinds of salts, then that say dissolve and then become a source of pollution. And then man-made or artificial, like disposed by humans from various sources, from industrial or sewage or other kinds of things. So that can be also causes. So water's physical chemistry includes acidity, like change in pH which shows, and then electrical conductivity, then temperature and eutrophication. So this all indicates say the what type of pollution is taking place. So the causes we can say by even physical examination, like the temperature, eutrophications or color or smell. From that also we can identify what is the cause of water pollution. So that also give initial assessments, and then some of the samples can be collected and then assessed to see that what kind of pollutions are there, and then accordingly we can look into the various aspects of the water pollution. So now let us look into the different types of pollutions, like water pollution types here. The pollutants can be say, as I mentioned, when some of the components are more or less say depending upon in the water which is particular for the specific use. So the pollution type can be organic pollutants, so like detergents, disinfection by byproducts, then food processing waste, fats and grease, then insecticides, herbicides, organohalides and other chemical components, then petroleum hydrocarbons including fuel, then lubricants, then fuel combustion byproducts, then tree and bush debris from logging operations, then volatile organic contaminants such as industrial solvents, then chlorinated solvents, denaples, and polychlorinated biphenyl, then trichloroethylene or perchlorate, and then various chemical compounds found in personal hygiene and cosmetic products. So the water pollution type can be organic pollutants or inorganic pollutants. So organic pollutants are what is given in this slide. So it can be coming from detergents or petroleum products or volatile organic compounds or various things we use for various cosmetic products or personal hygiene products. So these are all say type of pollution can be organic. So then another type is the inorganic pollutants. So here I have listed some of the inorganic pollutants. So like acidity caused by industrial discharges, like sulfur dioxide from power plants, then ammonia from food processing waste, then chemical waste as industrial byproducts, then fertilizers containing nutrients, nitrates and phosphates, and then heavy metals from motor vehicles, then silt or sediment in runoff from construction sites, logging, slash and burn practice or land clearing sites, etc. So these all introduce inorganic pollutants to the water. So the pollutants we can classify into two types. One is organic pollutants and the second one is the inorganic pollutants. So accordingly, once we assess the water samples through various lab tests, we can assess whether it is organic or inorganic, and then accordingly we can suggest a typical type of treatments for the water which we are trying to use for specific purposes. Then the pollution also can be macroscopic or microscopic pollutants. So here in this slide, macroscopic means it is a large visible items polluting the water. So this may be termed as floatables in an urban stormwater context, or marine debris when found on the ocean or open seas, like then trash or garbages, then dumping of rubbish, then nodules, small ubiquitous waterborne plastic pellets, shipwrecks, etc. So these are all under the category of macroscopic pollutants. And then microscopic pollutants like microorganisms within the water, then dissolved or dispersed pollutants, which is we cannot easily visualize these kinds of pollutants. Macroscopic type pollutants we can easily visualize and do the necessary treatment, but microscopic pollutants are concerned, we may have to go for various tests to identify what are the real pollution which is causing the within the water. So the pollutants can be either macroscopic or microscopic. And then as I mentioned, nowadays due to the say lot of water is used for say power generation and then cooling, we use a huge quantity of water. So, thermal pollution is a major source of pollution. So, let us look into this slide where some of the important aspects of thermal pollution is discussed. So, the rise or fall in the temperature of a natural body of water caused by human influence. So, this is the thermal pollution. So, thermal pollution results in a change in the physical properties of water. A common cause of thermal pollution is the use of water as a coolant by power plants and industrial manufacturers. Then elevated water temperature decreases oxygen levels. So, this is the side effect, like say when the temperature rises, the oxygen content reduces. So, that can kill the fish and affects the aquatic systems or the ecosystems. And urban runoff may elevate temperature in the surface waters like lakes or rivers or to the ocean. And thermal pollution can also be caused by the release of very cold water from the base of reservoirs into warmer rivers. So, both ways the pollutions are also possible, like cold water mixing with the warmer water. So, that way also possible. So, like that, so thermal pollution is also a major source of pollution in many of the systems, aquatic systems. So, that also we have to consider. So, now whatever we discussed so far, the sources of pollution, causes, types of pollutions, and then the macroscopic, microscopic or thermal type of pollutions. So, now say what are the important parameters of water quality. So, now let us discuss the water quality. So, what are the important parameters which we have to consider when we when we try to assess the given sample of water is good or bad, or what is the condition of the water. So, the parameters are very important. So, generally the following list of indicators are often measured, say when we are going for lab tests or what type of particular test. So, first one is the alkalinity. So, like say whether it is water is acidic or alkaline, that actually the pH indicates whether it is alkaline or acidic. Then color of water, then taste and odor, then dissolved metals and salts like sodium chloride, chloride, potassium, calcium, manganese, magnesium, etc. Then microorganisms such as fecal coliform bacteria, Cryptosporidium and Giardia labella. So, all these kinds of microorganisms. Then dissolved metals and metalloids like lead, mercury, arsenic, etc. Then dissolved organics like colored dissolved organic matters, then dissolved organic carbon, heavy metals, etc. Then pharmaceutical byproducts, then parameters. So, this type of parameters say so when we are trying to assess typical particular samples of water, we are trying to see various parameters, how it is what is the range of these parameters within the water sample. So, as I mentioned already, say this the parameters we have to see the range, and then depending upon what kind of use, whether you are using the specific water for drinking or industrial or irrigation purpose. So, accordingly the usage say or the treatment which we can go for, that varies. So, so these are some of the important parameters which we have to consider as far as the water quality is concerned. So, this water quality say as far as water quality is concerned, we have to consider certain environmental indicators. So, here the environmental indicators we can classify into three broad say three categories. First one is the chemical assessment, second one is the physical assessment, third one is the biological assessment. So, chemical assessment say generally what we try to do is say related to dissolved oxygen, then nitrate, then orthophosphates, then chemical oxygen demand COD, biochemical oxygen demand, then pesticides, metal, etc. So, these are some of the assessment which we will be trying to do as far as the chemical assessment is concerned. Then physical assessment is another important indicator, environmental indicator. So, there we will be trying to see the water sample is whether it is acidic or alkaline. So, this pH indicates whether it is acidic. When it is less than 7 it is acidic, and above 7 it is alkaline. Then what is the temperature range as far as physical assessment is concerned. Then total suspended solid, how much suspended solids are there, then turbidity of the water, then total dissolved solids. So, these are some of the major environmental indicators as far as physical assessment is concerned. Then the biological assessment, biological monitoring metrics we can develop in say depending upon the requirement. So, in many places these metrics are used, and then one widely used measures is the presence and abundance of members of insects orders like mayflies, stonefly and Cadiz fly, etc. And then of course, like the microorganisms, presence of bacteria and protozoa or other kinds of organisms within the water. So, that way the environmental indicators are concerned, it can be chemical assessment, chemical related, physical assessments or the biological assessment. So, now let us look into some of the important, as far as water quality is concerned, the important physical chemical parameters generally which we test as to assess the suitability of water for the specified use. So, as I already mentioned, it can be pH, which indicate whether water is acidic or alkaline, then color of the water, then taste and odor, then turbidity, TDS, total dissolved solids, total hardness, chlorides, sulfates, fluorides, nitrates, calcium, heavy metals, dissolved oxygen, pesticides, detergents and radionuclides. So, these are some of the important physical chemical parameters which we have to test and then see say how much is there for the particular samples. So, that we can specify whether the particular source of water is, whether it is suitable for drinking or suitable for the irrigation purpose or suitable for industrial purpose. So, let us look into some of these important parameters, what are those parameters, and then what is the range of these parameters. So, this pH is one of the important parameter which shows whether the water is acidic or basic. So, neutral, the water is said to be neutral then when pH is 7, and it is acidic when pH is less than 7, and it is basic or alkaline when pH is greater than 7. So, as far as say for example, drinking water is concerned, generally the pH should vary from 6.5 to 8. So, this is the range which is expected as far as drinking water is concerned, and also irrigation purpose also it is not good whether acidic or alkaline type water. So, this is almost the same range we generally prescribe as far as irrigation is concerned. And then another thing is that say mainly especially to see that the dissolved solids or the salts what is there within the water samples or water source we can identify through electrical conductivity measurements. So, actually this electrical conductivity measurement shows water ability to conduct electrical current. So, this depends on concentration of dissolved associated substances. So, say like say sodium chloride or potassium or various other kinds of dissolved solids, TDS, total dissolved solids, that is say the presence is indicated by electrical conductivity. So, to find the TDS say we can do specific test, and the unit is generally microsiemens centimeter. Then some of the other important water quality parameters like odor, color and taste. So, odor we can classify as very weak, clear, strong or very strong. So, this we can say do ourselves. So, odor of the water. Then color generally we can test using colorimeter tubes. So, this is expressed in Hazen standard units. So, generally for drinking water purpose the water should be clear. So, no color should be there. And then as far as taste is concerned, say the purest form of water like the distilled water, it is tasteless. So, but most of the drinking water there may be some kinds of say salts or some total dissolved solids will be there. So, some taste will be there. So, generally the taste we call it as palatable water depending upon the drinking purpose. Then another important component is turbidity. So, this turbidity is caused by presence of suspended matter and it ranges in sizes from colloidal to coarse dispersions, measured by Nephelo turbidity meter and expressed in NTU, nephelometric turbidity unit, and this indicate say whether the water is we have to treat, say for example, especially when we take water from rivers or lakes for municipal supply. So, depending upon the rainfall conditions, the water become turbid. So, we have to go for specific type of treatment like settlement or sedimentation or various processes for that type of water. So, this turbidity is an important parameter which we have to assess say especially for drinking water purposes. Then dissolved oxygen is another important parameter which we have to assess. So, dissolved oxygen indicates amount of oxygen gas dissolved in water, solubility of atmospheric oxygen in fresh water, and it may ranges from 14.6 milligram per liter at 0 degree centigrade to about 7 milligram per liter at 35 degree centigrade under 1 atmospheric pressure, and this is we can measure using dissolved oxygen meter, and then we can see how much is dissolved oxygen. So, this dissolved oxygen is very important as far as aquatic life is concerned, and then also various other uses like say human use is concerned. Dissolved oxygen we have to measure and then see how much is available within the particular source of water. Then other parameters like biochemical oxygen demand. So, this is another important water quality parameter which we have to test. So, here the amount of dissolved oxygen demanded by bacteria under during stabilization of the decomposable organic matter under aerobic conditions. So, that is what the BOD or biochemical oxygen demand indicates, and BOD is expressed in milligram of oxygen consumed per liter of sample during 5 days of incubation at 20 degree centigrade, and is often used as a robust surrogate of degree of organic pollution of water. Say for example, pristine river water, the BOD should be less than 1 milligram per liter. So, BOD is one important aspect which we have to measure and then see whether the water source is safe for drinking or other kinds of purposes. And then some of the other important parameters like nitrate. So, the nitrates the water soluble molecules made up of nitrogen and oxygen. So, the natural it is actually natural constituents of plants, and in natural form of water contains less than 1 milligram of nitrate. So, nitrogen per liter, and higher levels actually the nitrate is contamination. Common sources generally like fertilizers, animal waste, manures, and then maximum permissible is 10 parts per million or 10 ppm of the nitrates. Then another water quality parameter, important water quality parameter is so called chlorides. So, chlorides can come from dissolved salt deposit, discharge of effluents, etc. So, generally maximum permissible limit is 250 parts per million or 250 ppm. Then say some of the other important parameters like fluorides. So, fluorides can say it is mainly in say happens in groundwater or some of the other water sources. So, fluorides say it is the fluorine containing compounds then found naturally in low concentration drinking water and foods. So, fresh water it can be between 0.01 to 0.3 ppm, and ocean water contains say between 1 to 1.5 ppm. Maximum permissible limit for drinking water is 1 ppm. So, if it exceeds say fluorides, if it exceeds certain limits, then there can be problems like skeletal fluorosis, or if it is not there also so to certain extent like say 0.5 ppm or say like that, it should be available within the water. So, otherwise then say it can be up to say 0.3 is the say up to 0.3 it should be available within the water. Otherwise, there can be problems related to teeth and other related issues. If fluoride is less, it is problem, and also more than other types of problems can comes like skeletal fluorosis. Then another important parameter is hardness. So, this hardness represents total concentration of especially calcium and magnesium ions. So, this is also mentioned in ppm, say weight per volume, and hard water is generally not harmful to one's health, but can pose serious problems in industrial settings like boilers, say like precipitations, or say various problems can be there when we use hard water in the industry. So, we may have to make it soft depending upon the specific use of the water. Then another important parameter is iron. So, iron naturally occurring, and this is generally not hazardous, but the recommended limit is 0.3 milligram per liter. So, say this also comes naturally to the water. Then some of the other important parameters like heavy metals. Heavy metals can be arsenic, cadmium, chromium, copper, iron, manganese, mercury, nickel, silver, zinc, etc. So, present in as minerals in soils, this can leach with the rainwater or the surface water. Also artificially from man-made things sometimes also brings these heavy metals. So, some of these like major contaminations like arsenic or mercury or lead, these are all some of the major contamination as far as water is concerned, and these are generally determined by atomic absorption spectrophotometers AAS or polarography or colorimetry. So, these are some of the testing methods as far as the heavy metals are concerned. Say for example, arsenic is a major issue in states like West Bengal, and then generally this is due to overdraft of the groundwater, and especially wherever that kind of arsenic related say minerals are there, that leaches into the groundwater, and generally say as per World Health Organization guidelines it should be less than 0.5 milligram per liter. Then other parameters like pesticides which are harmful for health effects such as cancer, and then say for example presence of DDT, BHC, parathon or endosulfan etc. Say for example, this endosulfan is a major source of pollution in say northern Kerala and Mangalore region. So, this has created a lot of problems which are used mainly for cashew nut crops, and that comes to the surface water sources or groundwater sources. Then other parameters like detergents, phenol, radionuclides. So, World Health Organization guidelines are there in all this, it should be definitely less than 0.5 milligram per liter. And then halogenated chloro-organic compounds. So, this can be due to higher chlorination for disinfection. So, this also we have to control. Then of course, microbes like pathogens or bacteria or viruses. So, these are all indicator potential waterborne diseases. So, this also we have to control, say for example, coliform bacteria. So, these are all some of the important water quality parameters which we have to identify, and then we have to test it, and then if it exceeds certain say standards, say like World Health Organization standards or US EPA standards or Indian standards. So, then when it is exceeding these limits, so we have to go for specific treatments and then only we can use the water for that particular usage. So, now let us look into say what are the common water related problems. So, we can see that depending upon the presence of various contaminants or various pollutants within the water. So, say some of the effects we can directly observe within the water. So, like taste or like color or smell, all these things we can easily say visualize or taste it, so that we can easily go for various measures, or we can try to identify what are the sources of this type of pollutions. So, for example, when the water which we are storing or which we are using for cooking or other purpose, when water turns black or the smell is not good, then it can be say that source of water will be mixed with the wastewater, so that we can try to identify. Then say if any acidic taste is there for the water, then that means the pH is low, then alkaline means high pH. So, depending upon the source of water, it can, if acidic or alkaline is dangerous. So, generally for drinking or cooking purpose, the pH base should be between 6.5 to 8. Then say for example, while boiling say rice, say the rice become hard and yellow, then we can presume that alkaline, the water is slightly alkaline. Then white deposits on boiling, so that means say the water is hard. Then iron taste, change in color after exposure to atmosphere, change in color of clothes, utensils, oily appearance on top of water. So, here that means presence of iron compounds. Then soap not lathering, that means hardness. Then brownish black streaks on teeth, that means fluoride or related issues. Then growth of algae in the water source, that means presence of nitrates or phosphates. then say within the water available fish are killed, that means it can be less dissolved oxygen within the water or pH is less, and then if the taste is salty, then say more chloride is present. So, like that we can easily identify the observed problems and then we can try to identify the causes. So, now say let us look into water quality tolerance and classification. So, as per Indian Standard Institute's IS 2296 1982, the tolerance limits of parameters are specified as per the classified use of water. So, here classified into class A to E. So, types of use: class A drinking water source without conventional treatment, but after disinfection. Then class B outdoor bathing, class C drinking water source with the conventional treatment followed by disinfection, class D fish culture and wildlife propagation, then class E irrigation, industrial cooling or controlled waste disposal. So, let us look into these categories. So, for example, as given in the IS codes and reported in Ministry of Water Resource or Central Pollution Control Board, Government of India, some of the classifications are given here. Say pH should be 6.5 to 8.5, then dissolved oxygen should be the tolerance is 6, then BOD 2, then total coliform organisms up to 50, color hazen units 10, then odor should be unobjectionable, then taste should be agreeable taste, then TDS should be less than 500, total hardness should be less than 300. So, like that various say tolerance limits are given. Say for class A is for drinking water source without conventional treatment, but only after disinfection it can be used. So, this table gives limits of inland surface for class A water. Then class B, which we can say outdoor bathing and other purposes. So, here some of the tolerance limits like pH value should be between again 6.5 to 8.5, dissolved oxygen limit is 5, then BOD 3, then total coliform organism 500, fluorides 1.5, color hazen units 300, then say like say phenol compounds less than 0.005, like that. So, here this is for class B, which is for outdoor water usage like swimming and other purposes. Then class C is actually for here, as you can see that drinking water source with the conventional treatment followed by disinfection. So, this table again shows the pH value should be between 6.5 to 8.5, dissolved oxygen 4, BOD 3, then total coliform 5, same per 100 ml 5000, color 300. So, like that this type of specification you can see. Then class D, which is considered is for fish culture and wildlife propagation. So, there here the pH value again 6.5 to 8.5, dissolved oxygen 4, free ammonia 1.2, electrical conductance 1000, then say alpha emitters, beta emitters, say the 10 to the power minus 9, 10 to the power minus 8, like that. Then the last one is for the purpose of say irrigation and industrial. So, it can say here again the variation like electrical conductivity can be up to 2250, then total dissolved solids can be 2100, like that. So, like this we can see that say various standards are available. So, what are the tolerance limit is given as per IS standards here I have shown. So, according to WHO standards or US EPA standards or Indian standards. So, we can prescribe those standards and accordingly we can see that available water is suitable. Now, before closing, let us briefly see a case study related to water quality issues in India. So, in India water resources are overexploited resulting in major water quality problems. Common issues of surface and groundwater includes pathogenic bacteriological pollution, salinities, toxicity, then and other industrial pollutants. Then surface water, especially main issues like eutrophication, oxygen depletion, ecological health. Most of the lakes and rivers are highly polluted. So, these are some of the surface water pollution issues in India. Then groundwater is concerned the presence of fluorides, nitrate, arsenic, iron or seawater induction. So, these are some of the main issues as far as the water quality is concerned in as far as India is concerned. Then say some of the major factors which causes this kinds of degradation say domestic, industrial or non-point source, or say domestic sewage or sewage along with agricultural runoff. So, domestic say about 430 class 1 cities and 500 class 2 towns harboring population of say 300 million generate about 30,000 million liters of per day of wastewater, which only about 25% is treated. Then industrial, about 60,000 polluting industries in India generate about 15,000 million liters per day, of which only 60% is treated. The non-point source of pollution contributes significant pollution load coming from say especially overland and the agricultural sources. Then domestic sewage say main source of other type of pollution for surface water. Then sewage along with agricultural runoff and industrial effluents also contribute large amount of nutrients. So, then say here some of the figures taken from this Central Pollution Control Board. You can see that say the number of populations, then population water supplied, then wastewater, then treatment. So, you can see that what is varying from 1978 to 2003 is given. So, this amount is going up, but the treatment is also not going to that level. So, that is a major source of pollution water supply and sewage disposal status in class 1 cities. So, similarly very similar way, the similar trend we can see in class 2 cities. Then comparison of pollution load generation from domestic and industrial sources. Again see this red color shows the domestic and this blue color shows the industrial. So, again the BOD discharge or BOD generation, and then waste treatment. So, these things are shown in these figures. So, similarly river basins, let's say like major rivers like Indus, Ganges, then Brahmaputra, Sabarmati, etc. So, this red color shows where the BOD higher range, so blue color more than 6 milligram per liter, then red color between 3 to 6 and blue color less than 3. So, you can see that a major stretch of the rivers say there is problems. So, that way with the water qualities are concerned, major issues there as far as India is concerned, especially surface water, the river water, lake water. So, major pollution problems are there. So, Government of India through various agencies are trying to solve these problems, say like recent say river Ganga action plans to reduce the pollution loads. So, that various state governments are also working this direction. So, say private public partnership or people should come together to deal these kinds of pollution problems as far as surface water or groundwater is concerned. So, some of the important references used in today's lectures. So, before closing, some of the tutorial questions: critically study the water quality problems of major rivers, river basins in India, study various sources and causes, which details are given here. From this you can get. Study the various measures that can be adopted to reduce the river pollution or in river basins. Then some self-evaluation questions. Discuss the various water quality issues in watershed management. Describe various water quality categories. Then what are the different pollution sources types. Describe various water pollution causes. Illustrate water pollution by thermal sources. Describe various water quality parameters. Then few assignment questions. Describe water quality standards. Discuss various water pollution sources. Describe various specific sources of water pollution. Illustrate various water pollution types. Describe various water quality indicators. What are the various common water related problems. Now, finally, some unsolved problems. Critically study the possible surface water pollution problems in your watershed area. Identify the water sources and possible causes of pollution. What are the roles of agricultural land use and industrial other uses in the pollution problems, then prepare a plan to reduce the possible pollution problems. So, many of these questions like assignment or so self-evaluation questions you can answer by going through today's lecture. Other details are given. So, today what we discussed is the surface water quality issues and water pollution sources and then various parameters. So, further we will discuss this groundwater quality problems issues and then water quality modeling. Thank you very much.